Hey math fans, we're on section 2.6.1. Let's get started. Today we're going to be comparing linear functions. We're going to be identifying the rate of change for f of x, then the rate of change for g of x, the y-intercept for f of x, and then the y-intercept for g of x. And then finally, we'll summarize and compare the properties of each function. Example 1, the functions f of x and g of x are shown. Compare the properties of each. First of all, you want to identify the rate of change for f of x. If you use the point 0, 8, and you also use the point 4, 0, which are both clearly graphed, I wouldn't choose anything that doesn't match up with the grid. We can get a good calculation for the rate of change. As you can see, I'm using the rate of change formula right here, and you get a rate of change of -2. So with the rate of change of -2, we say on average, the f of x value, the y value, is decreasing by 2 as x increases by 1 between these two particular points. And g of x is located in a table. Since it's in a table and it is linear, it doesn't really matter which values you choose. We could choose -2, 10, and then we could choose -1, 8. But since it's linear, any set of ordered pairs will work. Using the slope formula again, we get that the rate of change for this function is 2. Back to f of x, what's the y-intercept? The y-intercept is located right here at 0, 8. For g of x, back to the table, the y-intercept here, when the x value is 0, the y-intercept is -6. So let's summarize and compare the properties of each function. The rate of change for the first function was -2, and the rate of the change for the second function was +2. We would say that since they are changing equally, in other words, one is positive and one is negative, but if we look at just their absolute values of the change in y versus x, they're actually equally steep. In other words, they're changing the same amount. They're just changing the same amount in two different directions. So we will say that they are equal rate of changes. The y-intercept of the first function is 8, but the y-intercept of the second function is -6. We would say that the y-intercept for the function f of x is greater than the y-intercept for g of x. Example 2, your employer is offered to pay 2 pay scales for you to choose from. I like these ones because if you were to have a choice between these two models, which one would you choose? One is modeled by the graph here, but the other one is kind of tough to see. It's modeled by this, a base salary of $250 a week plus 15% of the price of the merchandise that you sell. Okay, so we'll start calling this one will be f of x, and then this one down here is actually g of x. Notice that it's not the same. These two functions are not the same. So we'll look at each one of these individually. So for the first scenario, we'll call it f of x. We have a base salary of $250, and then we also get 15% of whatever we sell, which creates this equation right here, f of x is equal to 0.15x plus 250. Well, let's identify the rate of change. So the rate of change is going to be 0.15, and the y-intercept is going to be $250. For g of x, we have to use the graph. And we could choose any points that we want since this is a linear function. So I would say choose the intercept here. And we could choose another point like 500, 300. And we could just put these 2 points into the slope formula, and we get 0.2. The y-intercept for g of x is going to be this point right here at 0, 200. So let's summarize and compare the properties of each function. The rate of change for the second function is greater than the rate of change for the first function. In other words, it is changing more. The y-intercept for the first function is greater than the second. You will have a higher base pay for the first function. So the question is, which one sounds better to you? Would you rather have a higher base pay but lower per merchandise you sell, or vice versa? So that's obviously subjective and up to you. Example 3 says 2 airplanes are in flight. The function f of x equals 400x plus 1200 represents the altitude after x minutes. But then we have g of x down here represented by the graph. Compare the properties of each function. Again, we're going to choose a couple points. We're going to use the slope formula. We get the rate of change is negative 250 for the graph. And the rate of change, obviously, for f of x is already here at 400. So how does 400 compare to negative 250? And what about their y-intercepts? This has a y-intercept, f of x has a y-intercept of 1200, and then you have a much higher y-intercept in g of x right here. To summarize, the absolute value of the slope for the first function is greater than the absolute value for the second function, and the y-intercept for the second function is greater than the first. And that's going to do it for this section. We'll see you in class.